September 14, 1942. Kaiser Shipyard No. 2, Richmond, California. The welding supervisor handed Henry Kaiser the production report. Ship number 43, SS Robert E. Peary, launched today. Construction time, 4 days, 15 hours, 29 minutes, start to finish. Henry Kaiser, a construction engineer who had never built a ship before Pearl Harbor, studied the impossible numbers. 9 months ago, building a cargo ship took 230 days. What none of them knew was that this civilian contractor's revolutionary production methods were about to transform American industrial capacity and deliver the logistics capability that would win World War II. The United States faced a mathematics problem that threatened to lose the war before a single decisive battle could be fought. German U-boats were sinking Allied merchant ships faster than traditional shipyards could replace them. In 1942, U-boats sank over 6 million tons of shipping. American and British shipyards, using conventional methods, could produce approximately 3 million tons annually. The equation was simple and catastrophic. Every month, the Allies fell further behind. Without merchant ships to carry troops, weapons, fuel, and food across the Atlantic, the war effort would collapse regardless of military victories. Britain would starve. The Soviet Union would fall. The invasion of Europe would become impossible. Traditional shipbuilding had remained essentially unchanged for centuries. Each ship was a custom project. Skilled craftsmen built components individually. Riveting required experienced workers who had trained for years. A Liberty ship, the standard cargo vessel design, required approximately 1.5 million rivets. Each rivet had to be heated, inserted, and hammered by hand. Master riveters could place 100 rivets per day. The mathematics were unforgiving. 1.5 million rivets divided by 100 rivets per day meant 15,000 worker days of riveting alone. Multiplied across all construction tasks, the timeline stretched to 230 days minimum. The United States Maritime Commission had designed the Liberty ship based on a British tramp steamer. Length 441 feet, beam 57 feet, draft 27 feet, displacement 14,450 tons, capable of carrying 10,000 tons of cargo at 11 knots. The design was deliberately simple and old-fashioned. Triple expansion steam engine rather than modern turbines. Coal-fired rather than oil-fired to conserve petroleum. Single propeller shaft. Minimal crew accommodations. These ships were never intended to be fast or comfortable. They needed to be built quickly, in massive numbers, by workers who had never built ships before. Henry Kaiser was an unlikely revolutionary. Born in 1882 in upstate New York, he had built roads, dams, and bridges. His company constructed the Hoover Dam, completing it 2 years ahead of schedule. He understood mass production, standardization, and logistics, but he had never built a ship. When the Maritime Commission requested bids for Liberty ship construction in 1941, traditional shipyards dismissed Kaiser as unqualified. Todd Shipyards, Bethlehem Steel, Newport News Shipbuilding, these companies had built ships for generations. They knew the 230-day construction timeline was already aggressive. Suggesting faster production was naive. Kaiser studied the Liberty ship plans with an engineer's eye for inefficiency. Every custom component represented wasted time. Every skilled craftsman requirement created a bottleneck. Every sequential construction step extended the timeline unnecessarily. He saw not a shipbuilding problem, but an assembly problem. The automobile industry had solved similar challenges decades earlier. Henry Ford's assembly line had reduced Model T production time from 12 hours to 93 minutes. The principle was standardization and prefabrication. Instead of building each car individually, Ford manufactured standardized components that could be assembled rapidly by semi-skilled workers. Kaiser proposed applying the same principle to shipbuilding. The traditionalists were horrified. Ships were not automobiles. Salt water, Heavy seas and enormous stresses required custom fitting and experienced judgment. Prefabrication would produce weak joints and structural failures. The ships would break apart in rough weather. Kaiser was undeterred. He secured contracts to build 30 Liberty ships at a new facility in Richmond, California. The shipyard didn't exist yet. He would build the shipyard and the production system simultaneously. Construction began on the Richmond shipyard in January 1942. Kaiser recruited workers from across the country: former farmers, housewives, mechanics, teachers, anyone willing to work. Over 90,000 people eventually worked in Kaiser's Richmond shipyards. Most had never seen an ocean. The average age was 37. 42% were women. The training program lasted 1 week. Traditional shipyards required apprenticeships lasting 4 years. Kaiser's system eliminated the need for traditional skills through radical standardization and prefabrication. Instead of building ships from the keel up, assembling each component in place, Kaiser divided Liberty ships into modular sections, built separately in vast assembly halls. The hull was divided into 250 prefabricated sections. Each section was built on the ground, where workers had easy access and optimal working conditions. Overhead cranes moved components. Gravity assisted assembly. Workers didn't need to climb scaffolding or work in confined spaces. The most revolutionary change was welding instead of riveting. Traditional shipbuilders insisted riveting was superior. Riveted joints were stronger and more reliable. Welding was experimental and dangerous. Welds could fail catastrophically under stress. The Titanic had been riveted. The technique had proven itself over centuries. Kaiser's engineers disagreed. Welding was faster, lighter, and actually stronger when done correctly. A single skilled welder could complete work that required 4 riveters. More importantly, welding could join prefabricated sections rapidly. The challenge was training welders at scale. Traditional welding required years of training. Kaiser developed an intensive 2-week welding school. Students learned one specific type of weld for one specific application. Instead of training general welders, Kaiser trained specialists. One person learned to weld deck plates, another learned keel joints, another learned bulkhead seams. Each worker mastered a single skill and repeated it hundreds of times, achieving speed and consistency through specialization. The assembly sequence was redesigned around prefabrication. In traditional shipyards, the keel was laid first, then the frame was built upward, piece by piece. Each component had to wait for previous work to complete. Sequential construction stretched the timeline. Kaiser's system built multiple sections simultaneously. While workers assembled the bow in one hall, others built the stern in another. Engine room sections took shape in a third location. Deck houses were prefabricated, complete with plumbing and electrical systems. Each section was a modular unit that could be built independently. The final assembly became almost like connecting building blocks. Massive cranes lifted prefabricated sections, each weighing up to 90 tons, and positioned them on the shipway. Welders joined the sections. The entire process took days instead of months. Production statistics revealed the transformation. The first Liberty ship at Richmond, SS Ocean Vanguard, took 244 days from keel laying to launch. The second ship took 150 days. The 10th ship took 60 days. By the 50th ship, construction time had dropped to 40 days. The learning curve was exponential. Each ship taught lessons that improved the next. Workers identified bottlenecks and solved them. Engineers refined the prefabrication sequence. The system became more efficient through continuous iteration. Robert E. Peary represented the culmination of these improvements. Built in 4 days, 15 hours, 29 minutes from keel laying to launch, the ship was fully functional, passing all inspections. She sailed under her own power and served throughout the war, surviving until being scrapped in 1963. The 4-day ship was a demonstration project. Kaiser wanted to prove what was possible with full prefabrication and optimized workflow. Every component was prepared in advance. 3 shifts worked continuously. Over 4,000 workers participated. The prefabricated sections were assembled like a giant puzzle. 45 minutes after the keel was laid, the first bulkhead was welded in place. 6 hours later, the engine was installed. Was it Durand's? 12 hours later, the superstructure was complete. 36 hours later, the ship was recognizable. 4 days later, she slid into the water. Critics argued the 4-day ship was a publicity stunt that didn't represent sustainable production rates. They were partially correct. Maintaining that pace was impossible. But the demonstration proved that radical acceleration was achievable through proper organization and prefabrication. The sustainable production rate stabilized at approximately 2 weeks per ship across Kaiser's 7 shipyards. Richmond Shipyard No. 2. The largest facility launched a Liberty ship every 5 days on average. The mathematics had been transformed. 230 days reduced to 14 days, a 16-fold improvement. The cumulative impact was staggering. Traditional shipyards using conventional methods produced approximately 1 ship per year per shipway. Kaiser's yards produced approximately 26 ships per year per shipway. One Kaiser shipyard could outproduce 5 traditional shipyards. By 1943, Kaiser's 7 shipyards were producing over 1 Liberty ship per day collectively. The United States built 2,710 Liberty ships. During World War II, Kaiser's yards built 1,490 of them. Over half of total production came from shipyards that didn't exist before the war. Managed by a man who had never built ships before, the Industrial Revolution extended beyond shipbuilding. Kaiser's prefabrication techniques influenced aircraft production, tank manufacturing, and housing construction. The principle of modular assembly became fundamental to American mass production. Not every Liberty ship was built in record time. The average construction period across all shipyards was 42 days. Some ships took longer due to material shortages, labor issues, or design modifications. But the transformation from 230 days to 42 days represented a production revolution that changed industrial warfare. The quality concerns raised by traditional shipbuilders proved partially valid. Some early welded Liberty ships suffered catastrophic failures. Hulls cracked in cold weather. 3 ships broke completely in half. The brittle steel fracture problem was eventually solved through metallurgical improvements and better welding procedures. But the failures highlighted real risks in rapid production. The Maritime Commission investigated each failure and implemented corrective measures. Better steel alloys, resistant to brittle fracture, improved welding training and quality control, reinforced stress points where cracks typically initiated. By 1944, the structural problems had been largely resolved. The strategic impact exceeded even optimistic projections. German U-boats continued sinking Allied ships throughout the war, but American shipyards were now producing ships 3 times faster than U-boats could sink them. The mathematics had reversed. Every month, Allied shipping tonnage increased, despite losses. By 1943, U-boats were losing the Battle of the Atlantic, not because they became less effective, but because American production overwhelmed them. The Liberty ship program demonstrated that industrial capacity could be multiplied through radical reorganization, rather than incremental improvement. Traditional shipyards focused on building better ships. Kaiser focused on building ships better. The distinction was fundamental. Prefabrication required enormous upfront investment. Kaiser built specialized assembly halls covering millions of square feet, overhead cranes costing hundreds of thousands of dollars, welding schools training thousands of workers, storage yards for prefabricated components. The infrastructure investment was massive, but the return on investment was extraordinary. A traditional shipyard building, 1 ship per year, generated minimal return. A Kaiser shipyard building, 26 ships per year, generated revenue that justified any infrastructure cost. The economics of mass production made extreme specialization profitable. Kaiser's success attracted imitators. Other shipyards adopted prefabrication techniques. The Todd Bath Iron Shipyard in Portland, Maine, used similar methods to produce British-designed cargo ships. The Delta Shipyard in New Orleans built tankers using prefabrication. By 1944, prefabrication had become standard practice across American shipbuilding. The civilian workforce proved remarkably capable. Women welders, nicknamed Wendy the Welder in propaganda campaigns, achieved quality ratings equal to male workers. Older workers brought manufacturing experience from other industries. The one-week training program, dismissed as inadequate by traditionalists, produced workers capable of meeting stringent quality standards through specialization and repetition. Post-war analysis revealed the Liberty ship program's true significance. The ships themselves were adequate but unremarkable. Slow, simple, built to minimum standards. Many were scrapped shortly after the war ended. But the production system represented a paradigm shift in industrial organization that influenced manufacturing for decades. The total cost of the Liberty ship program was approximately $3 billion. This produced 2,710 ships with a combined cargo capacity of 38 million tons. The equivalent investment in traditional shipyards would have produced perhaps 800 ships with 11 million tons of capacity. The return on investment through innovative production methods was over 300%. Kaiser's fame extended beyond shipbuilding. He became a symbol of American industrial ingenuity. Magazine covers featured him as the man who was winning the war through production. His shipyards became tourist destinations where Americans came to watch Liberty ships being built at impossible speed. The propaganda value reinforced public morale during the war's darkest periods. In Richmond, California, the shipyards that employed 90,000 workers at their peak now stand mostly empty. A few buildings remain as museums, documenting the Liberty ship era. The last Liberty ship in active service, SS John W. Brown, operates as a museum ship in Baltimore, Maryland. She still steams under her own power, a testament to the durability of the design. The prefabricated hull sections Kaiser pioneered continue to define modern shipbuilding. Every commercial vessel today is built using modular construction techniques descended directly from Liberty ship production methods. Container ships, tankers, cruise ships, all are assembled from prefabricated sections built in optimal conditions and joined at final assembly. The principle that a civilian contractor with no shipbuilding experience could revolutionize the industry seemed impossible in 1941. Traditional shipyards had centuries of experience. Their methods had been refined through generations. The idea that road-building techniques could transform ship production appeared naive. Henry Kaiser proved that fresh perspective and willingness to challenge tradition could overcome institutional knowledge. By treating shipbuilding as an assembly problem rather than a craftsmanship problem, he multiplied American industrial capacity at the precise moment when the war's outcome depended on logistics and production. In the cold mathematics of industrial warfare, Kaiser's contribution was definitive. 230 days, reduced to 4 days in demonstration, and 14 days in sustainable production. One civilian's impossible trick made Liberty ships appear fast enough to win the Battle of the Atlantic, support the invasion of Europe, and sustain the Pacific campaign. The steel hulls carried victory across the oceans, and the production system that created them faster than enemies could sink them proved that American industrial ingenuity was itself a decisive weapon.